everybody for being here for the Passive House Component Spotlight with 475 High Performance Building Supply. We're really happy that you have joined us today. And the Passive House Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and we elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, video, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. My name is Zach Semke. I'm the director of Passive House Accelerator, and I'm going to be playing the role of Q&A concierge today. So as questions occur to you during Nick's presentation, please type them into chat, and I will be tracking those questions. And when Nick's presentation is over, I will be inviting folks to ask their question live for Nick. So you'll unmute yourself, and if you feel comfortable, turn on your camera and you can have some interaction with Nick at the end of the program. So Nick Shaw is product consultant with 475. He's a FIAS certified consultant and builder, and he's familiar with a variety of high performance techniques as a self-described sustainable design nerd. So we know he's in the right place. Nick has been working in the green building field for 11 years, primarily on integrated design build projects, and he has a BA in environmental studies with a concentration in environmental education from Warren Wilson College. We're really excited to have Nick here, and Nick, please take it away.
Thanks so much for having me. I'm a huge fan of what the Passive House Accelerator is doing and all the great webinars and online get-togethers that have been happening. So thanks so much for hosting this. I'm with 475 High Performance Building Supply. We're a material supplier that services all of US and Canada. We had partnerships with manufacturers mainly from overseas, and then we're making their high performance solutions available in the States and Canada. I'll kind of give an overview of the suite of solutions that we offer and keeping it very building science, passive house oriented throughout. At the end, I do have some different wall assemblies that we can kind of talk through for a variety of construction types. Please put your questions in the chat or throughout, and we'll discuss further at the end. But 475 actually gets its name from the International Passive House Standard. 4.75 kBTU per square foot per year is the annual heating and cooling demand for International Passive House certified projects. So we are founded out of doing passive house projects specifically. It's where we like to say the blower door is king. I'll sound like a broken record about how important air tightness is. For those who don't know, the blower door is a giant fan that's used to pressurize or depressurize the building envelope. So on site, you can literally measure how airtight the project is. And that air tightness metric is something that we're working into our energy models and sizing our systems and such based on that. We do like to really prioritize air sealing. I will be talking about air tightness, which is different than vapor control, which is different than water control, bulk water, which is also different than thermal control. All of this is a holistic approach where we're kind of having a balance of these different things. But we prioritize air sealing a lot more than thermal insulation, thermal control, or vapor control, partly because air is where most of the moisture is coming from. Air is inherently really wet, really moist. So this is a study from the Building Science Corporation looking at one heating season, one winter. Gypsum is airtight, but vapor permeable. So just through diffusion, we get 1/3 of a quart of water move through it. But then when we puncture a 1 square inch hole, we get 30 quarts of water. So air is really moist, it's really wet. So we really want to prioritize air sealing. And actually, ideally on both sides of the wall assembly. On the exterior where it'll be your house wrap, that's typically vapor permeable for climate zones 4 and up. And then on the interior, we're having it double as our vapor control layer using vapor variable membranes nowadays. But along with air being really wet, there's this idea of thermal bypass or wind washing, where you can get air convection loops moving throughout your insulation layer. When a manufacturer gives you the R value of material, that is from a lab facility where it's airtight on both sides of that bat, that board, that blown in loose fill, whatever type of insulation it might be. So a job site is not a lab facility, and things can go wrong, and we can get wind washing within our insulation layer. That can greatly reduce the R value up to 79%. So that's fundamentally a different wall assembly at that point. So that's one reason why we prioritize having air sealing on both sides of our insulation. This is the PHPP summary sheet, the International Passive House Certification Energy Modeling Program. It's actually the world's first passive house project completed in 1991 in Darmstadt, Germany. This is just a theoretical exercise where we're leaving everything about the project the same R value, same building orientation, everything's the same. We're just changing how airtight the project is within the energy model to see how that changes or affects our annual heating demand and our heating loads. It's in metric, but we can get the gist of it. So 0.22 ACH 50, air changes per hour at 50 pascals of pressure. That's a volumetric measurement of air tightness. At 0.22, that's incredibly airtight. Passive house for new build is 0.6. So when we're at 0.22, we're then showing a 14 kilowatt hour per square meter, or 10 watts per square meter. So that's extremely energy efficient. That's very, very airtight. We then move to 0.6, which is the passive house standard for new builds under the international certification. We're now at 12 watts per square meter. We then move to 1.5, which I would say is like the pretty good home approach, or what Building Science Corporation recommends. We're now at 17 watts per square meter. We then move to 3, which is current code for climate zone 4 and up under the new energy code, and we're at 25 watts per square meter. And then we move to 5, ACH 50, which is old code, untested, unverified, don't really mean much, and we're at 36 watts per square meter. So this is to say that whoever's sizing your mechanical systems should care about how airtight the building is. We do get a lot of energy loss through an air leak. Regardless of the level of insulation, making your home more airtight will make your equipment and overall building more energy efficient. So this is how we can appropriately size mechanicals when we're doing an energy model, and be including how airtight the project actually is. It's also why the builders on site need to verify with the blower door test to show that they met the level of airtightness that the engineer was planning on. So we're really prioritizing air sealing nowadays. And at 475, we like to say less is best when it comes to spray foam or any foam-based material. We're not really seeing spray foam as part of the solution. Rigid boards can have their place when we're comfortable being vapor closed, but in general, we want to be avoiding foam-based materials. It's partly because of the toxic ingredients. It does off-gas. It's a flame accelerant. It's unreliable for performance. Actually is not dimensionally stable and will shrink over time and uplift off of the substrate. But a big reason is because of the environmental impact. Passive house is really all about the operational carbon use, how much energy it takes to heat and cool the building. But we're also trying to consider the embodied carbon, how much energy it takes to extract those raw resources and turn it into a building material. And we know that we need to really prioritize this because climate change is a crisis. It is happening right now, and we need to do what we can to actively reverse or mitigate climate change. So really prioritizing embodied carbon, using plant-based materials, materials that were carbon sequestering when it was alive, and then we cut it down, turn it into a building material so it's carbon storing. That would be like any plant-based material. And there have been different studies done to show that looking at 2050 as our timeline, that our operational carbon is a big component of it. That's what Passive House is all about, but our embodied carbon, our material sourcing heavily outweighs our overall energy performance. And that's carbon loading that happens on day one, while operational carbon use is over the lifespan of the building, how much energy it takes to heat and cool the building. So we really need to be addressing the immediacy of climate change, and we do that through our material selection. So we can actually make our buildings carbon negative or carbon storing for the lifetime of the project. So Passive House as a standard, this is the Cornell Tech project out on Roosevelt Island in New York City, 26 stories. This was panelized construction with a full suite of 475 materials for those panels. We're doing Passive House for skyscrapers. We're doing it for single family, all types of projects where we're doing Passive House now. We want to prioritize those air ceilings. Solutions. And this is all an integrated methodology. We can talk about this as energy efficiency, but we can also talk about it just as comfort and indoor air quality. And I find I kind of shift how I'm talking about it based on the audience. A lot of the homeowners of Passive House projects are comfortable paying high energy bills. So they're partly doing it for the comfort benefits, for the indoor air quality benefits. And this integrated methodology is rooted in continuous insulation, thermal bridge free, really thinking of the building like a thermos, which does mean we need to have triple pane windows that are airtight. We're making the whole building airtight. And then we're putting in some mechanicals, an HRV, heat recovery ventilator, or an ERV, energy recovery ventilator, to be supplying balanced, fresh air that is filtered and coming in at a comfortable temperature. So we make the building airtight, and then humans need to breathe. So we put in some active ventilation with an HRV or an ERV. This is the 475 website. There's the US version or the Canadian version. We are e-commerce setup. So you can purchase wherever through the website, and we ship all over US and Canada. And a resource to put on everyone's radar is we have developed a set of ebooks, which are best practice assemblies for a variety of construction types. They come in PDF or DWG files. And it's a good resource to be having some precedent for what these assemblies should be looking like. And these are high performance foam free assemblies that are highlighting the use of the 475 systems. So this is free to download through our website. Check out our website. Our blog's really fantastic. A lot of good case studies and building science articles. We have a robust social media with a lot of good photos and also a good YouTube page. That's both like product overviews, but also more case studies and interviews with clients. So getting into the suite of the materials that we offer. And when I'm looking at wall and roof assemblies, I do have an order of importance of how I think about things. Shedding the water is number one. This is why we went into caves to begin with. Kick the water as far away from the building as possible. That's what architects are very familiar with. Then we're prioritizing air tightness, partly for the reasons I was getting into before, in terms of it holds a lot of moisture. It disproportionately affects other things. We are building our walls and roofs very thick, or including a lot more materials to really limit the amount of energy that moves through that assembly. Which means we're no longer baking our assemblies dry with our heating and cooling equipment. So we need to think about how that assembly is going to dry through diffusion. And that's why we really care about the vapor permeability of the materials that we're using. Vapor control is different than air tightness. And then lastly, we're looking at thermal control, or R value. Trying to be thermal bridge free, or really prioritizing having those warm interior surface temperatures. which will reduce condensation issues, but also create a much more comfortable interior for our occupants. So the suite of things that 475 offers, we're offering membranes, tapes, gaskets, for the exterior side of our assemblies. These are monolithic membranes that require active vapor transport along a molecular chain. Most technology that was previously available in the States was microporous membranes. These are membranes with little pores within them, and that's how they allow moisture to pass through it. Those pores can clog or deteriorate over time. Wood tannins break down those micropores. So we're offering a suite of materials that are higher performing, more durable. And what's nice about with it being monolithic is also that we can have the same membrane be the wall as well as our pitched roofs. That would be the Solitex Mento membranes or the Adhero membranes for a fully adhered version of that. So these are truly airtight, truly watertight, but vapor permeable or vapor open membranes for the exterior side of our assemblies. We do like to prioritize a rain screen for our walls, creating a drainage plane and an air gap behind our finished cladding for the walls. And if we have vertical siding, then we need to do what's called a counter batten approach, which is 2 layers of battens. Whatever's against the house wrap, your WRB, does need to be running vertically to allow that airflow and drainage. We're doing a similar thing for our pitched roof systems as well. I would say if you're having a roof pitch of 312 or greater, it is best to vent those pitched roofs. And oftentimes we want to have rafter tails from an aesthetic look or to create bigger eaves to kick the water away. That can be a thermal bridge concern. With the rafter tail, it's also an air leak concern. So we're oftentimes doing what we call applied rafter tails. Here on the left image, we're showing the same membrane as the wall and roof, acting as our water resistant barrier. Then we put in these notched timbers that are acting as those rafter tails. And then we kind of use that to start and then create our vented roof assembly. So we're allowing drainage and airflow from the eave to the ridge. You can vent to lower pitched roofs, but you then need to make the vented gap even greater. But we are not venting flat roofs. Flat roofs need to be vapor closed up top because we could have standing water in those locations. We have mechanically fastened membranes, but we also have peel and stick membranes, fully adhered membranes. This is the Adhero membrane. It's a really good solution for mass timber projects. Really great to have all plant-based materials, full plant-based assemblies, whether it's Clt Cross-Laminated Timber or NLT or GLT. These are different types of wood panels that can be acting as a structure as well as our interior finishes. So for multifamily projects where we're using the Adhero membrane as that CLT protection on the floor to keep the assembly dry during the construction phase. Similar suite of materials, we offer fluid applied, which means brush on, spray on, or roll on air barriers. So this is the Viscon, where we're using it to treat any uneven surface, such as masonry, but also to help with a lot of air barrier transition details. Sometimes it's difficult to be placing a membrane, so instead we can be coating some framing or other material in the Viscon to act as that air barrier transition. So we have the standard Viscon, but also a version with fibers built in that can bridge larger gaps. So the standard version can bridge 1/8 of an inch, while this fibrous built-in one can bridge more like 3/4 of an inch. And upcoming, we'll also be offering a version of this that comes in sausage tubes. And then there's this spray gun that attaches to your standard air compressor. So this is a way where you don't need a different type of airless sprayer for the application. You can be using your standard like nail gun compressor for this. And this will come for Viscon and Viscon fiber and these sausages, and we'll be releasing that in the next month or so. Follow us online, join our newsletters, and see us on social media for the release of this different packaged material. Very excited about it. So here we're showing interior air barrier transition. We have the Intello membrane. It's going to meet a top plate. We can then tape it to that top plate and then use the Viscon to transition through that subfloor system. So that's the black that you're seeing here, where we're treating the joints where the rafters, where the joists meet the rim joist, as well as where the subfloor meets that rim joist and the top plate meets the rim joist. So you could wrap a membrane around, or you can be using these fluid applied materials to air seal in between and make that transition so it's complete and continuous air sealing. So focusing on an interior air barrier, we offer a suite of gaskets, tapes, membranes for the interior side of the insulation. Here we're showing the Intello membrane. The Intello membrane is actually vapor variable. So it is airtight, but changes its vapor permeability based on the relative humidity around it. So in the winter time, our vapor drives naturally from the interior towards the exterior. Cold air is drier air. Cold air holds less moisture. So we have a lower relative humidity, and thus this membrane is acting as a class 2 vapor retarder at 0.17 perms. Then our vapor drive actually changes direction in the summer. It's hot and humid outside. It's more comfortable on the interior, so our natural vapor drives from the exterior coming in. We have warmer air that holds more moisture. We have a higher relative humidity. So this membrane becomes vapor open or vapor permeable up to 13.2 perms to allow the assembly to dry inwards through diffusion. So we're opening up before we're at the risk of mold growth. So this material changes its vapor permeability based on relative humidity, which correlates to our vapor drive and our seasons. What this looks like on a vapor curve, we have vapor permeability on the vertical, we have relative humidity on the horizontal. You can see different vapor curves for other vapor variable membranes. At about 70% relative humidity is really a throttle point, where we want to be going from as vapor impermeable to as vapor permeable as possible. Mold grows or accumulates at about 80% relative humidity. Anytime you're above 41 degrees Fahrenheit, below about 104 at 80% relative humidity, mold growth. So we want to allow the assembly to dry inwards through diffusion before we run the risk for mold growth, which is why that 70%-ish relative humidity is kind of a throttle point. Some other membranes open up too soon or too late. And we've really found through testing that this Intello membrane opens up at that kind of sweet spot. So we're greatly reducing moisture risk within our wall and roof assemblies. And in general, we do want to prioritize an interior air barrier. There's kind of two different approaches for durability of these high performance assemblies. One is to do a dew point analysis, where you're putting enough exterior insulation to warm the sheathing layer. That's a fine approach, but it doesn't really account for how quickly our climate is changing. And we've been seeing some more natural disasters or greater changes in weather patterns and such to show that we can't really be working with existing climate data as much. So another approach is having an interior air barrier. This holds your warm conditioned air off of the colder sheathing surface. So now we don't worry so much about that dew point analysis, where we're letting the sheathing layer get colder. We're just holding our warm air off of it. So that's a way that we're preventing condensation against that sheathing layer. It also means the air barrier is in a location where you can mend and fix it. So if your builders aren't quite hitting the blower door numbers that they want, then they're able to access that air barrier and fix it up. It can now also double as your vapor control layer, and that's where that vapor variable membrane with the Intello becomes really key. So just having an interior air barrier that's vapor permeable is really helpful, but you get even greater risk reduction when that interior air barrier is vapor variable, as we now say, or smart. That's what the Intello membrane is offering. This is right behind the drywall, and we need to protect it. Think of the drywall as a sacrificial layer, not as an air barrier. You can go online and read about the airtight drywall approach, but it has a lot of durability concerns. Every time you hang a picture, it's compromising that drywall airtightness. So instead, we're running a service cavity. This protects that Intello membrane, but it also now creates a chase for us to run our electrical equipment, so that way we're not piercing or interrupting that Intello membrane. It makes our buildings more adaptable. It means that the next homeowner can come in and run new electrical without interrupting the rest of that structure that's good for 100+ years. So we're allowing access to certain areas of the assemblies while limiting access to the other areas of the assemblies that have longer timelines for maintenance. This also is a location where you can throw another bat insulation if you need some greater R value. And the depth of the service cavity is really just based on the depth of your outlet boxes, or whatever you want to place in there. I am seeing plumbing being kept all on interior walls, because those are much bigger diameter pipes and such. So that would make our exterior walls even thicker. So here we're showing that service cavity with coming into a tilt turn window. The window is being taped directly. The window is your air barrier in that plane, as well as your vapor control layer, your insulation. We're asking a lot out of our glazing. We are using triple pane nowadays. That interior air barrier will pose sequencing concerns for your contractors. They need to know about these interior air barrier transitions. And this does happen at the framing stage of things. So image on the left is a construction team putting in just a sliver of this membrane, or a floppy bit, as we say, of the membrane. And then they come in and frame in an interior wall. And if they didn't place this little floppy bit of membrane, now that interior wall is interrupting where we would want that air seal. So that does complicate these types of details. So if they know and have this air barrier on site at the right time, it will keep the costs down and folks moving along really quickly. This will happen at our floor transitions as well. You can just put a ledger directly over it and just run a continuous. Or a lot of folks are calling wrapping the rim joist, where you're putting the floppy bit of membrane onto the top plate, setting down your floor structure, lapping this membrane over and around the rim joist, and then framing your next wall on top of it. So that way your subfloor assembly is pinching the membrane between the top plate and bottom plate of the walls above and below. And now you have these floppy bits of membrane that you can tape to down the line. So you will see these loose bits of membrane on site during the framing process of these projects. And this is just keeping folks moving real fast and staying on schedule. But it is something that they need to know about and have these materials on site during the appropriate times. Here we're showing just placing this membrane during the framing stage. We like to use a fairly robust membrane at this location. That can be the Intello X membrane or the Mento membrane, because we are creating quite a few pinch points where we want to make sure that we're not tearing the membrane. You can just fasten directly through the membranes, install with staples. You just want to hit the structure behind it to pinch the membrane at that fastener. Here we're showing just placing your joist hangers directly through the membrane, and now you're taping to it above and below. So there's a variety of ways to do these types of air barrier transitions. Flat roofs, kind of coming back to that for a second. For flat roofs, we are not venting them. There's no pitch to create a pressure differential. The pitch is solely just for some drainage. We will have standing water up there. So we want to be all vapor permeable because the top is vapor closed. Or if we are using a rigid foam board, we want to make sure we're not creating a vapor sandwich with anything plant-based in between, nothing that could break down or deteriorate from moisture damage. So if you're topping with a rigid foam material, make sure your protection board is a masonry sheathing board and not a plywood or OSB plant-based material. On the underside of the deck, we're getting a lot of fibrous insulation, natural vapor permeable, that could be mineral wool bats or cellulose. And then we're running the Intello membrane on the underside. And the Intello becomes particularly key, one, to have an interior air barrier, but two, for that vapor variability because the exterior is vapor closed. So now we can't dry through diffusion towards the exterior. So we can only dry inwards. We don't want to moisture load the assembly when it's trying to dry outwards. So check out, we have a blog post specifically called 10 Golden Rules for Foam Free Flat Roofs. And that'd be a good blog post to be looking at for flat roofs. They are inherently tricky. And now we're also mounting photovoltaics up top. We're putting a living roof up top, which is making things even riskier because now we're not getting the solar gain on that membrane to push the vapor drive inwards, but it's still achievable. We are taping to our windows and doors. The caulks that folks used to use would harden and crack over time, so it's not a reliable air seal. We also want to be vapor permeable, so we're not can foaming in windows anymore. We're vapor closed on the exterior sill because we could have standing water on that horizontal surface, but otherwise we want to be vapor open as much as possible. We don't want to vapor dam, especially where we have a high temperature difference, which is more likely to have condensation concerns right there. The corner taping is a little bit of some funny origami with the tape. I do oftentimes have contractors pre-cut their corner taping, go around and install just the corners, and then come back and do the rest of it in long strips. It's an easier way to be playing quality control because the corners are the higher risk point for these installs. We can pre-tape windows. Triple pane windows are incredibly heavy, and not all projects have the opportunity or luxury to be able to put it on a sawhorse and pre-tape it. But if you are able to do that will really simplify things. You use painter's tape just to hold your air sealing tape down in the meantime. And then you set your window in place, stuff your fibrous insulation. Here we're showing mineral wool, and then fold that tape up and get your final air seal connection there. So here we're showing a plywood buck on the right and some Vanna on the left image. The plywood buck on the image on the right, you would want to tape the seams as well as the end grain of the plywood. So that is something where you can get air movement between the plies of plywood. Less of a concern with OSB since it's just a bunch of glue, but OSB tends to be more vapor closed or more of a true vapor retarder. So we prefer vapor permeable sheathings typically. Into the mechanical systems that we offer, heat recovery ventilation. These are directly through the wall, no ducting needed. This is from Lunos as the manufacturer. This is only available in the United States through 475. There's the E2 system, which works in pairs. When one unit is exhausting, the other one is supplying air. And then there's a different system called the E-Go that's designed for restrooms. It's a single hole through the wall, but there's two fans in there. So that's how we're still keeping a balanced ventilation. And the E-Go has an exhaust-only mode for when you're taking a hot shower. You don't need a system in each room. You just need to allow airflow from one unit to the other. So we're undercutting doors or somehow allowing airflow from one unit to the other. We're doing a lot of single-family homes with this Lunos system. We're doing a lot of multifamily as well, where the Lunos is being used just for direct fresh air for the units, the apartment units, and then typically there's a centralized ducted system for the stairwell or other kind of shared spaces. So it's really helpful, this through wall HRV. Whenever you don't want ductwork, then Lunos will be helpful. And it's really nice for renovations for that reason as well. Staying within our mechanical systems, domestic hot water heater. It's a heat pump water heater where the tank is separate than the heat exchanger. So the heat pump lives outside of the building envelope, and then there's just water piping connecting the two. The refrigerant is carbon dioxide, and that is fully contained within the heat pump. So this is not a mini split, it's not a VRF system. It's just water piping connecting the two, only for domestic hot water use. You can have multiple tanks to one heat pump or vice versa, and that's how we're kind of sizing this for a single family home or multifamily, everything in between. Glazing, we have a whole lot of skylight options coming from Lamelux, triple or quadruple pane, Passive House certified components. Also exit hatches, so really helpful for townhouse renovations. These come with the curb pre-installed, so it's already thermal bridge free, airtight. And then this flange that you're seeing, that just goes against your deck, and then you lap your EPDM or TPO up the curb, and so it's a really simple install. So whatever you need in Passive House level performance for glazing options. Also windows and doors from OptiWin, triple pane wood framed aluminum clad windows and doors from OptiWin. Again, high performance Passive House appropriate. Getting into the insulation that we offer, this is a Gutex wood fiber insulation. This is manufactured in Germany. There's different types of Gutex boards. It comes in boards that are tongue and groove that can actually shed the water on the exterior. There's also butt joint boards, there's bats, there's blown in, really good thermal performance, really good acoustical performance, vapor permeable, and can act as your house wrap or roofing underlayment for pitched roofs in one. So it's really nice when we're getting dual function out of one material. So this will replace your house wrap and exterior rigid insulation. It is not structural. You will need to have something to pick up your shear strength. We can offer a 1 hour fire rated assembly. It's a Class B fire rating. Currently not quite tested to a 2 hour fire rated assembly. But we have options for 1 hour fire rated assemblies. Getting into the embodied carbon side of this, wood is fantastic. When it's alive as a tree, it's sequestering carbon out of the atmosphere. It stores that in the wood fibers. We then chop it down and turn it into a building material that then locks in that carbon storing for the lifetime of the project. So this top one, we're looking at how the embodied carbon changes. The gold color or yellow color is just what's the carbon stored in the wood fiber board itself. And then the blue is when we're actually making it into that product. So we're now having some carbon loss from the transportation and manufacturing of that. The wood fiber is heated to a temperature to kill any of the nutrients within the wood fiber. So there's nothing that insects or bugs like to eat within that wood fiber. Then the gray color is actually still being carbon negative when it gets off the boat and sent to the Connecticut warehouse on the East Coast. And then the orange color is getting off the boat and being delivered to the Oregon warehouse on the West Coast. So even though it's manufactured over in Germany, it's still carbon negative when it's getting off the boats in the US, no matter where in the US you are. In the lower right, we're showing just overall embodied carbon numbers comparing different types of insulation. So EPS or XPS, XPS is incredibly high embodied carbon out of the rigid foam board. So if you are using a rigid foam board, it's best to use an EPS or polyiso just from the environmental sourcing. Mineral wool, stone-based, has a pretty carbon-intensive manufacturing process. cellulose or multi-therm, the wood fiber, that's where we're getting carbon negative. And then best case is actually when we're using like agricultural waste products, plant-based materials that would otherwise get decomposed or somehow have the carbon released back into the atmosphere. So we really want to prioritize negative embodied carbon materials or plant-based materials. Sheep's wool insulation, really high R value per inch of 4.4. It comes in bats or blown in. A really good option for like DIY homeowner driven projects, doing a lot of tiny house and like van renovations with this type of material. And then we have design PH or the Phpp. These are the giant Excel sheet that's used for the International Passive House certification. And check out our website. We offer a little bit of everything within the high performance world. Again, download our ebooks and then check out our blog and our YouTube and follow us on Instagram and other social media. And I do have some wall assemblies that I can be discussing and kind of moving through to show some examples, and then we can be getting more into the Q&A side of things. And I can come back to these as we need to. But first, looking at 2x4 or 2x6 assembly. On the right is the interior. So we have our drywall finish and then our service cavity, which we can be insulating with the batt material or leave it uninsulated. Then we're installing the Intello Membrane, the Intello Plus for wood framed. Then we're putting in blown in insulation or batt, something vapor permeable within our cavities. That could be cellulose, that could be mineral wool, that could be fiberglass. Then we're having our structural shear strength or sheathing, whether that's plywood or OSB or diagonal strapping. If we were using mineral wool, then our house wrap would be placed against that sheet good of the plywood. If we're using Gutex multi-therm, then that acts as your true house wrap. So then we're just having the rain screen outboard of that, and then we're hanging whatever siding on outboard of that. Just a different image of the same assembly. And very similar for metal frame. For metal framing, we do want to prioritize more exterior insulation because the metal framing is a more conductive material. So we need more insulation to help eliminate the thermal bridge of the metal framing. Historic masonry retrofits. So this, let's say it's a landmark building and we can't touch the exterior, which is the left side. From the exterior moving in, we have our 3 white brick existing. Maybe we're doing some repointing or something to help shed that water. Then we're treating the interior side of the masonry so it's at least wind tight, as we say. That could be a lime plaster, or sometimes repointing is enough, but best practice would be to coat the viscon, the fluid applied air barrier. We're then holding our new framing a little bit off of that masonry to help insulate in between. That could be a 1/2 inch or whatever is needed based on a therm model. And then we're framing in a wall and having the Intello membrane, that's the red dotted line, acting as our vapor control layer and our interior air barrier. And we're using fibrous insulation, vapor permeable, mineral wool, cellulose, fiberglass, whatever it might be. Then we're having that service cavity and interior finish. Just different image of the same idea. Again, these are all directly available, free to download through our website. These are our smart enclosure ebooks. Double stud assemblies, big fan of double stud. We have our interior finish on the right. We have our drywall, our service cavity, our Intello. We're then distancing our stud framing based on how much R value we're trying to get in there. We're typically using cellulose for a double stud assembly. We then have our shear strength on whichever wall is structural. That tends to be the exterior wall, but it can be the interior one. Then we're running a house wrap that's vapor permeable. That'd be the Mento membrane or the Adhered membrane. And then we have our rain screen and siding. Different just render of it. An I-joist assembly or a Larson truss, let's say it's a retrofit, or again, interior on the right, we have our existing 2x framed wall. we're leaving that, not really touching it. This is a really good approach for occupant in place retrofits. We're then air sealing the sheathing layer. That could be taking the seams, that could be running the Intello membrane, that could be Adhered. We're then putting a wood framed outrigger. The depth of that is based on how much R value you're trying to get. We then run the Solitex Mento Plus membrane, which has a netting built in to support dense pack insulation such as cellulose. We dense pack that, cellulose, mineral wool, fiberglass, whatever it might be. And then we have our rain screen and our finished siding. Just different view of that. And then lastly, we're showing a Clt Cross-Laminated Timber. And this is where the wood is our interior finish and structure. We then air seal with the Intello membrane that's also acting as our vapor control layer. And then a really thick layer of the Gutex wood fiber that's acting as our house wrap. And then we have our rain screen. Same thing for a pitched roof. But thanks so much for taking the time, and now we can be opening it up to conversation.
Fantastic, Nick. That was really good. You packed in so much great information and building science as well into your presentation. I think people really enjoyed it, and there are a ton of questions. And I have some fun news, and that is that Sean St. Amour, who has been traveling all over British Columbia recently, is back in the saddle and able to play the role of Q&A concierge today. So you all are in good hands. Sean is with 475, of course, and is also the co-host of Construction Tech Tuesday and plays the role of Q&A concierge at every Global Passive House happy hour. So Sean, please take it away.
All right, we got lots of questions, Nick. Here we go. Jason, you have about 4 questions. So why don't you start with one and then we'll get back to them. So pick your most important one and we'll get back to you once we go through the list because there's a long list.
Okay, cool. Now I can't remember what question I asked because I did several of them. Let me go to the very beginning here. Let me see. I think my first question was, the blower door reading. Now everybody's always talking about air tightness at the 0.6 air changes an hour for passive house, but that doesn't necessarily mean that you meet the 4.75 heating and cooling requirement. Is that correct?
Correct. The heating and cooling sizing of the system is different than air sealing. They do affect each other. How airtight your building is will change your heating and cooling demands and loads, but there are different metrics within the passive house standard that you're trying to hit. So one is annual heating and cooling, a different one is air tightness. So it is this integrated methodology where we're looking at it holistically. So air tightness is a pathway to these other performance goals.
Okay. And I think I asked, I was just wondering if anybody prefabricated like different sides of those applied Raptor tails. I know that they're made on site by most people, but however, if you're using a template and you're cutting these things, a lot of times hopefully the carpenter, whoever's doing that, keeps the pattern good and all the same, because we probably want a really good tight fit up against the building without any gaps. So I was just wondering, I think someone answered that you might want to go to your local truss company and maybe just have them make them for you, which could be a good idea. But I was just wondering if there's maybe a manufacturer that if you gave them the details, they might be able to make those Raptor tails.
Not that I know of, but I would think you could speak to whatever truss supplier, or I am seeing folks just doing that template and making them on site.
I don't know if I had another one. I just want to give out to the shout out to Howard Stern, Baba Booey, because someone's using Howard Stern's name, and I don't know if it's the king of all media or not, but that's all.
We'll never know, but I think he's in the queue here, so we'll find out. Right, thanks, Jason. Over to John Snell.
Could you talk about how you prevent mice, rats, and other critters and insects from chewing building materials? The plant-based materials are great. I've had problems with them eating soy-based materials. How do you prevent the critters and insects from eating the building materials?
I would say that's a big advantage of air sealing on the interior. You're holding your warmer air within your conditioned space. So now you're not having your warm air go through the assembly, which is then creating a nice area for some critter to nest in. So there, you can be using materials that have active insect repellents in it, whether that's chlorates or ammonium sulfates or whatever other type of chemical treatments. But I would say the main thing is don't give them a reason to go there to begin with. So that's rooted in good air sealing and good vapor control and waterproofness. So you're not giving a nice warm, wet area for whatever to nest in. But yes, that is a constant uphill battle to ensure we're not getting pests in our rain screens or whatever it might be.
Thanks, John. And over to Megan.
Where you were showing the roof assemblies, where you were continuing the membrane from the roof down to the wall, was that just for cathedral ceiling applications, or can you do that for vented attics in some way as well?
You could do it for vented attics, but then I would say your roof membrane's just shedding water and not an air barrier for your roof assembly. If you're venting,
that's what I thought.
Then your air barrier would be in the top floor ceiling plane. So that's a totally fine approach, but I am seeing a lot of folks go with a cathedral ceiling, partly because with those vented attics, you don't want to locate any mechanicals up there. You don't want to have any ductwork going from your conditioned space to unconditioned. That's how we get a lot of condensation build up in our ducting. So you can use it just for storage, but you really shouldn't be locating any mechanicals in an unvented, in your vented attic in the unconditioned space.
All right, yeah, perfect. That applies to me right now. I've got a project that has that cathedral ceiling because we put the mechanicals up there. So I'm gonna take that back and double check my eave detail on that. Thank you.
Yeah, check out our ebooks. I'll show different options for this as well.
All right, thanks, Megan. And we're now headed over to Robert Haw.
Hi, Nick. Thanks for the discussion. So we were talking about embodied carbon, and I was just wondering what's the embodied carbon content of the intelligent house wraps? Intello, Solitex. Is that a significant contributor?
It's not significant enough for us to bother measuring it, I guess. And the membranes and such are such a thin material, and the amount of energy it saves from its performance justifies us using a small amount of petroleum material. So everything has some level of embodied carbon, but Proclima, the manufacturer, I don't believe has done embodied carbon or life cycle assessment of their products quite yet. They've done different testing in terms of toxicity, and that's what the Declare label is all about, or other stuff from the Living Buildings Certification or Living Future Institute. But I don't believe there has been any life cycle assessment or embodied carbon or global warming potential numbers put out for Proclima materials quite yet.
Okay. And just I had a second question, just real quick, I think. Are the Lunos E2s, are those battery powered?
They are hardwired. So the pair or number of pairs gets wired to the same transformer and controller. From that transformer and controller, it's just low voltage wiring to the actual fans. But you are hardwiring from your breaker or whatever to that transformer and controller.
All right, over to Bronwyn.
Yeah, hey everybody. Hi Nick, thanks for our presentation. I'm looking for fire rated assemblies, specifically for the wildlife urban interface regulations in California, because pretty much every building I'm designing needs to now comply with that based on our lovely summer conditions here. So you know, you touched on one assembly briefly that was 1 hour rated with the Gutex, and I just wanted to know if you have more that you can.
Yeah, I would say with the wood fiber installation, we haven't done like NFPA 285 testing quite yet. There are some assemblies that we think it would meet that 2 hour fire rated assembly. And if you have a large enough project that justifies us doing that testing, then please let us know. We're looking for projects that will help us justify the costs of those tests. Those are very expensive tests. So we've gotten the individual boards tested and 1 hour fire rate assembly, and we were open to other testing, but it's just the funding to do so, and needing to have a project that is justifying that cost. So yeah, if folks out there are working on larger scale stuff or multifamily projects or things like that, please reach out to us. And we want to work with you to get these things tested and more widely implemented.
And Nick, one other thing related to this is I wonder how the air sealing contributes to that, if at all. I'd be very curious to see if there has been any, you know, comparable testing between a more airtight assembly and a less one with a fire, you know, influence of fire. I'd love to see that data sometime.
Yeah, I'd love to see that data as well. It's actually a reason why I kind of like fire caulk, because it stays nice and gooey, and just to prevent flame spread, we want to prevent air movement. So a lot of best practice in terms of fire rating stuff is rooted in air sealing. And like the wood fiber boards, partly why it works well is that it's a dense enough material to prevent that flame from propagating. Similarly to why like straw bale can be fire rated. It's just the bales are packed dense enough to not get enough air movement through that actual material to propagate the flame.
Ron, that's a Kevin Brennan question. You got to show up to the Passive House Accelerator Construction Tech to get that answer. So I'll keep you with that. And he's actually mentioned it a few times, but I'm not telling the answer. You have to go check out the old videos. Moving along over to Lindsay Klein.
Hi, everybody. Nick, thank you very much. On the subject of Kevin Brennan and on construction tech, he did a part, and this has to do with my question. He did a part where he was showing that if you used plywood to hold the cellulose in, you could get a much better pack of it. So on my job, we've got cellulose between our studs, and we have the Intello product. And our general contractor, who has worked with Kevin, had yesterday proposed using the plywood, but I think he thought that it was plywood instead of Intello. So, and then I saw in your section, one of your sections, you had both. So I assume you would say best practices would be both. Is that correct?
For the interior side of the installation, you would want just the Intello. Plywood can be airtight, but it's not manufactured to be airtight. So if it's at least 5/8 of an inch thick and you tape the seams, it might be airtight, but you would have to blower door each sheet to actually know. So I would say that's the like Passive House Light or Pretty Good Home approach, but not true Passive House certification, where you want to know the material you're using is made to be airtight.
Okay, so it doesn't make sense to use both. It makes sense to, if you're having one, use the Intello.
For the interior side, I would say the plywood's normally on the exterior side of the cellulose to act as the shear strength. Plywood is a little bit vapor variable just because it's a wood-based material and the pores in the wood expand and contract a bit, but it's not nearly as vapor variable as the Intello membrane. So Intello is a higher performing option, and it does have the netting within to help support the cellulose. But I am typically seeing folks install that service cavity to help further support the cellulose from billowing or blowing out or anything like that.
Thanks.
But yeah, thanks, Lindsay.
All right, over to Annie Murphy.
I just had a question about Intello. So I find it's not a hard sell to clients because, you know, the performance comes through when we do the blower door test. However, I've always struggled to explain how it works, and it's a smart material that makes me feel dumb because I don't get it. I was just wondering if you could just tell me what it's made of and how I could describe that to people.
Yeah, thanks, Annie. The simplified explanation that I use is, so it's active vapor transport along a molecular chain. And if we can picture that molecular chain like runs on a ladder. And so if there's a high relative humidity, all the rungs are on that ladder and the water molecule can pass through. But if it's a lower relative humidity, then some of the rungs are missing. Maybe there's 2 here, but then there's a few missing. So you need enough moisture in the air, enough high enough relative humidity to bridge the gap of those missing rungs. And that's why moisture passes more freely once we're at a higher relative humidity than a lower one. When we're lower relative humidity, there's rungs missing in that ladder. And we're using the ladder as an analogy for that molecular chain. So it's not super simple, but it's something, you know, if you can picture rungs on a ladder, but some rungs are missing, is a way to talk about it. Yeah.
Cool. That's a great analogy.
Yeah. Are you using that in your natural building projects on the interior side of straw or anything like that, Annie?
No, more like deep energy retrofits.
It's good to see you again. I recall you from Yes Tomorrow days. People should check out Yes Tomorrow in Vermont. It's a really great sustainable design build school.
Thanks again.
Excellent.
Thank you.
Great question, Annie. I know when I started with 475, I struggled with trying to visualize that process too. And of course, Nick was giving me the answers then and giving us great answers today as well. So good one. All right, moving along over to Hank Keating. Hank?
Hi, my question is actually kind of a follow-up to that very same issue. I used Mento and Intello on my double stud wall 5 years ago. I'm comfortable, but what kind of testing has been done over time with Intello to demonstrate that the performance, which still seems magical even after that latter explanation, that it works? How 5 years, 10 years, 20 years from now?
Yeah, we're doing a lot of hygrothermal analysis through Whuppie, which does project out a number of years. And we can set that timeline in that modeling program. That's kind of it's part of the Whuppie program. There's the energy modeling side that's used for Passive House Institute, the US certification. There's a hygrothermal risk assessment modeling side of the program as well. So I would say we do a lot of simulated testing in that through that modeling program. There have been projects that are putting in sensors in their assemblies. I recommend everyone should be doing this. We need to be putting in sensors typically against the backside of the sheathing in our assemblies to show that what we're modeling on a computer is real, or really how reliable it is, just as you want to see your energy bills and how that correlates to your energy model. We need to do a similar thing. I've worked with OmniSense as the sensor manufacturer, OMNI Sense, but there's loads of options out there, and that was just the one I'm familiar with.
If I could just butt in real quick, this is Johnny from 475. To add on to that, I do the marketing, and so I follow the R&D head of Proclima on our Instagram, whose name is Luder Herms. And something he likes to do is to test that exact thing, because the company started in the 80s, so they have buildings as old as almost 30, 40 years old that have the Proclima products in them. He regularly tracks them in Germany, pulls out the material after that amount of time and does physical tests on them to make sure they're still performing. And it's kind of incredible because he documents this stuff on social media and you can see it. But it's up to snuff. They keep performing, decades later, which is pretty incredible. One in particular was the DB Plus, which, to answer one of the other questions about fossil fuel content, DB Plus is the alternative to Intello that's paper-based. So that's something to mention as well. But that was one of the tests he did, 30-plus-year-old membrane, and had it turn out great. So
thanks, Johnny, for hopping in. Always great insight. Rebecca is unable to answer a question, so I'm going to answer it for her. I just have to find it quickly because we got lots of questions we've gone through, and her question was, Nick, what are the options for installing an air barrier in a retrofit to overcome the continuity problems of floors, interior walls, and roof transitions?
You can do all the work from the exterior side of the sheathing, or you can do it all from the interior side. But whichever side you choose, you're going to have to remove most everything to that point. So you can do all of it from the exterior, air seal at your sheathing layer, insulate outboard of it, install your rain screen, and then your siding. You can leave all the exterior intact and remove your interior drywall finish, but then you will need to be taping around floor joists or rafters that would interrupt the Intello membrane, or that's also where the fluid applied, the spray on, Viscon can be really helpful for creating that air barrier continuity through floor systems. The devil is in the details in these high performance homes. So for most of the wall, it will be nice and simple, just run a membrane. But whenever we're changing material or plane, that is where it's going to get more complicated. So you can do it either way. There's no one right way to do this. There are wrong ways to do this. But there's a lot of really good ways to be approaching these projects. So choose one side of the assembly and try and do all the work on that one side. I have had projects use like top plates to transition from the interior towards the exterior, similar things at like your mud sill, but that gets trickier, and it's hard to play a quality control when you're trying to transition through a material that you can't visually inspect.
Oh, good point, Nick. All right, moving along to Bo Green.
Yeah, I'm just wondering about penetrations in the membranes, like the Mentos or the Gutex. What, you're stapling it, you're nailing it. How much can you abuse it and still maintain its integrity?
So most of these membranes are mechanically fastened. Mm-hmm. And if the staple is flush with the membrane, it will pinch it and stay airtight. So you don't need to tape over all of your staples. If someone hadn't quite figured out the pressure setting on their pneumatic stapler yet, then maybe you want to tape over some of those staples. You do want to tape the seams. And for any intentional holes, whether that's a wire or a pipe, you can tape or gasket around it. So the gaskets are an EPDM membrane with an adhesive strip built in. So that EPDM is like flexible enough, and then they just come in different sizes based on the diameter of the pipe. Or you can pinch a piece of tape around a wire, or use a bunch of little pieces of tape to feather around a pipe, which is what we call hula skirt taping. So where we are taping or gasketing around whatever penetrations that go through these membranes. Okay. But your electrician and plumber will come in and puncture a bunch of holes and probably not tell you about it. So you do need to follow behind your trades. And the larger the project, the more important it is to have like an air boss, someone whose job it is to ensure the project is airtight and stays airtight throughout the construction phase.
How big does that person need to be, the air boss? Like really tall? Big?
Yeah, a little over 6 feet probably.
Like 350 pounds?
Enough to make sure they can really crunch the person that's causing all the holes. Or, and again, if they don't want to be called an air boss, they could be the big ass, the air specialist, air sealing specialist. So depending on what they want to be called, we can give them a name.
All right, good news.
But again, it takes a team, right? You got to document things and got to make sure the team's open to telling about the holes so people can fix them properly and have some signage like we've got behind me here. So make sure communication through the entire process.
Yeah, a smart air sealing specialist.
No, Jeff's left us, so we're gonna head over to Phpp. I apologize if I'm not even gonna try pronouncing your beautiful last name. So
that's okay. Just inquiring on if you look more into the commercial side, would the Mento be able to hold the ballast on it? An inverted roof, where the waterproofing is right on the concrete deck.
Sorry, this was a commercial. You sounded a little faint, but a commercial project with a flat roof, is that the question? So for that top membrane, we do still want to be vapor closed because we could have standing water in that location. So I'm typically seeing that be an EPDM or TPO membrane. Projects are using the Intello Membrane, the fully adhered membrane, as a temporary roofing underlayment. So against the flat roof deck, they will apply this membrane and then top with their rigid installation and then their finished membrane. And the purpose of that membrane is to keep the assembly dry during the construction phase. And then it's a version that is vapor permeable, so you can leave it in place instead of tarping or untarping every day. So the 475 suite of materials tend to be airtight and vapor permeable to a certain degree. And we are using vapor closed materials like below our concrete slabs or when we're touching against the grade or on the top side of flat roofs. So that will be relying on vapor closed materials, whether it's like a Stego polymembrane or a Delta product or something similar.
And over to Darcy in Toronto.
Right, okay. Thanks, that was a great presentation. I actually now have two questions, but my first one was the heat pump water heater. What's the minimum outside air temperature that it works at?
So the coefficient of performance or energy factor does change based on the outdoor ambient air and what water temperature setting you have at the heat pump. It functions to extremely freezing conditions. I believe it's a negative Fahrenheit number that it's still functioning to a certain degree. But the colder we get, the lower energy factor or the lower coefficient of performance we get. They did just recently release the Gen 4 heat pump that came out this past winter, which is a higher performing version of the system. The heat pump is a little bit stronger and does have a better energy factor. But I would have to double check the specs of what the lowest temperature setting it is still functioning at. But it functions to a very, very cold temperature, but you do get diminishing returns in terms of that energy factor performance. And if you're extremely cold areas, then you definitely want to be insulating and heat taping your outdoor water piping and trying to mount that heat pump against an exterior wall. So you're having 4 inches of outdoor water piping instead of a few feet.
Right, yeah. Yeah, this is like Northern Ontario where it's like minus 20 degrees Celsius, which I don't know what that is in Fahrenheit. It's really darn cold. And then I guess my second question is we're kind of upgrading older existing cabins. So they have like 2x8 studs. And so we're just insulating that, but we'd like to put on a plywood on the interior finish. What happens if you do that on top of your vapor barrier, your Mento? Like you're combining two things that are maybe, are they conflicting or does that work?
I would say if the Intello membrane, that would be the interior one, is against the material that has a lower vapor permeability, then the upper limits of the Intello's vapor permeability are negated. So let's say the plywood has a perm rating of 5 and the Intello gets up to 13, but it's directly against it, then the max perm you're getting is 5 because you're in direct contact with the Intello with that ply. So you'd still want to have something that's truly airtight, but maybe that's a reason to just use the Mento membrane since you're negating the vapor variability of the Intello with the plywood. So now you just need something that's airtight and more vapor permeable than the plywood. So we have options for those types of solutions.
Right. Okay. Thank you.
Yeah.
And I did just look up the Senko 2, the most recent, I believe Gen 4 specs say ambient air operating range is -25 to 104 Fahrenheit, and -25 Fahrenheit would be -31 Celsius.
Wow.
And Darcy, I was just in Smithers, BC, and they have 3 Sannons, and I mean, you're getting to -25, -30 there. And I also know there's been a couple in Whistler for 5+ years, and they bought it just to kind of check the temperature, and they've been working fine. So, you know, it does work in these colder temperatures.
Hey, thanks.
Thanks, Johnny. And moving along to Tom.
All right, thanks. I just want to say on the sanding thing, we just installed a sand water heater on a passive house we completed just before winter. And I'm in Chicago, we had a real great polar vortex. So it's working great, except the installer forgot to turn the heat tape on. So we had a frozen pump and he had 5 days with no hot water. So the heat tape's great, but you know, it's like everything else, you got to turn it on. Nick, thank you so much. And I just love what you guys are doing at 475. I mean, you're giving us all this information, and I'm sure you do it because it helps drive business, but boy, is it helping the building culture in this company. So in this country, I mean, so anyway, thanks for that. My question is about under slab insulation. We're able to get away from foam so much, but that's one place we really can't. I think the last thing, we did do foam glass once, but I think that's embodied energy is pretty high too. On the graph you showed, the XPS, of course, looked worse than EPS. I was just wondering if that's the HFO blowing agent, which is a heck of a lot better than the HFC that they used to do. In other words, how do XPS with HFO and EPS stand next to each other for underslab? Do you know?
I know there has also been some new technology development in XPS to try and use blowing agents with lower global warming potentials. I have not seen the new numbers on those, on these new XPS products. Also, there's so many different grades of EPS. That's sort of like, what are we comparing it to? So the higher density EPS boards, I believe, I don't know the embodied carbon number comparison of type 4 versus type 6 EPS, for example. But not all foams are created equal. They're kind of all different. And I am seeing folks use mineral wool below concrete slabs. I am still seeing a rigid foam material or a gravel type of material, the recycled foam glass material for beneath point loads or footers in general, where we need a higher density or higher compressive strength out of our insulation. Another approach is called a frost skirt, or some folks call it a Swedish skirt, where at the perimeter you insulate outboard and kind of horizontally down instead of underneath the footer. And now the location of underneath that footer, there's a greater distance to travel before we're at ambient air conditions. So that's a way to be using insulation below grade that doesn't need to have the compressive strength for footers. But yes, I'm uncertain of the various new types of XPS or different grades of EPS in terms of embodied carbon comparisons. But none of it is ideal. So less is best when we're trying to use this foam-based stuff. But yeah, I'm really proud and happy to be with 475, and I think it is rising tide lifts all boats, like as just an industry, as we move towards these higher performance solutions, it will help everyone and set precedent for standard code to catch up to. So I look forward to Passive House or similar being standard code, and I think we are heading that direction.
Bravo, thanks.
Thank you.
Thanks, Tom. And moving over to Zoe Kaufman.
Thank you for answering all these questions so nicely, and good to see you. So my question, I don't know if it's particularly for 475 or just for this community in general, or what really, but you do talk about hot water heat pumps and about ventilation. So I'm throwing an HVAC question out. Whether any of you have seen centralized heating and cooling systems that are like low GWP or lower embodied carbon these days?
So I think a lot of the refrigerants that are lower global warming potential tend to be refrigerants that we need to use at a higher higher pressure. So like carbon dioxide is a really good refrigerant, but it needs to be at a really high pressure to be functioning properly, which means they tend to be in a small panel that's typically attached to your heat pump, or a vending machine, for example, uses a lot of carbon dioxide refrigerants. The VRF systems or mini splits that we have to run greater distances are at a lower pressure. And those do tend to be more harmful global warming potential refrigerants. And I would say where I'm seeing the industry head with using more benign refrigerants, they do tend to be carbon dioxide ones or similar that need a lot of pressure for them to work effectively, so tend to be a small panel. I don't quite know what this means for the future of mini splits and VRF systems. I'm a huge fan of mini splits. It's really nice to have heating and cooling in one, and we when we're doing Passive House, we need a 1/2 ton system instead of a 2-ton system or whatever it might be. But those refrigerants do leak over time. And we're running them great distances within our building envelope on the interior side of our air barrier. And that inherently makes me uncomfortable. So I think that is an area where hopefully technology will step up. And we as professionals need to drive the industry and show that market that, hey, we want to be using refrigerants with global warming potential, and here's 100,000 projects that we're looking to renovate and do this type of thing with. So we need to show the manufacturers that there's a need for this. But those refrigerant companies are pretty used to working on their toes, like the whole ozone depletion issues of refrigerants that were 15 years or so ago. That's now all outdated, and now we have a new slew of problems to be addressing with refrigerants. But I would say that is an area where the industry is moving pretty quickly, and also an area where there's so much room for growth. If folks want to get on board with the drawdown movement, which is about like actively reversing climate change, not just addressing climate change, the refrigerants are really like the #1 thing within our built environment, that the global warming potential numbers are astronomical. And for those who don't know, environmental product declaration, EPDs, which kind of give like, it's kind of like the nutrition label for building materials. They show embodied carbon, but it's only under global warming potential. And a lot of folks talk about global warming potential when talking about refrigerants, because that is the potential of that refrigerant getting leached out into the atmosphere, not just what it is when it's fully contained. So people use embodied carbon in different ways than global warming potential, which is also different than life cycle analysis. Life cycle analysis is looking at the waste side of the material, but people use them interchangeably or distinct them depending on who you're talking to. But yes, there's a lot of room for growth in refrigerant use, and I hope there'll be more benign chemicals in use. And yeah, it's good to see you today.
Yeah, I agree. Thanks. And if anybody knows of anything up and coming, let me know.
Yeah, dump it in the chat. We can have more conversations. But again, this is why passive is great, is we're talking about 90% less energy and then using smaller equipment to then give us the heating and cooling we need to make our places the comfortable on the weeks we need it. All right, over to Devin.
Hey, Nick, great to see you. Awesome work. And thank you so much. And Zach, thank you so much. And Sean, I can't believe that you're like driving all this way and you're sitting here. That must have been a heck of a drive, man.
I'm home, man. Go ahead.
So I don't really have that good of a question now that I think about it, but it's more like it's a marine application. It's actually like a boathouse in like New York, and it's always high humidity. And I know this is probably a woofy question really, but in terms of general strategy for applications, or just kind of just woofy and figure it out from the hygrothermal model. Because it's like sitting up over the water, and it's salt water, and it's like not that far from the water, and it's always high humidity there. It doesn't get touched by the water liquid, but the vapor is just always there through evaporation.
Yeah, so I would say then most projects that are climate zone 4 and up, we want to have a vapor open exterior, because we say that's a heating dominated climate. So thus our vapor drive's more happening towards the exterior. But when you are marine or coastal or a literal houseboat, then you do want to have a lower vapor permeability on the exterior. So you might want a class 2 or class 3 vapor retarder for your exterior house wrap. The Intello Membrane over OSB or plywood or something like that. But yes, I would say in general, like a woofy would be that risk assessment tool to help highlight which out of whatever option is lower risk. And I would say in general, you want to prioritize having a lower vapor permeability on the exterior.
Cool. Thanks a lot. Great work. It was a really excellent presentation. Thank you.
But I've always been fascinated by houseboats, partly because I don't think there's any building code for a houseboat.
It's not really a houseboat. It's like actually it's like a houseboat, but it's actually like a marina style, but it's just above the water. But it's like a houseboat basically, but it doesn't float. Not by itself.
Gotcha.
So anyway, yeah, maybe we'll connect offline about it. Thanks a lot.
Yeah, we got about 4 or 5 more, and some of them have multiple questions. So we'll see how long it takes to get through this, but we're getting close to the end. Patricia Partridge, you're up next.
Oh, great. I'm so impressed. I'm so impressed by the amount of knowledge you have, and also your honesty about the products. Thank you very much. I was so happy to see your detail about the brick wall with the air gap and the 2x wall inside. I've been for a couple of weeks trying to figure that out. I have a project just like that. It was, I had EPS, I took it out of because of the embodied carbon, and I put cellulose between the studs instead. But you don't show anything, you don't show any sheathing or anything on the brick side of the 2x wall. 2 questions about that. One is the stability of the wall. I have 2x12s running way too long, probably like 17, 18 feet. So that wall needs to be stable. And the other thing is, how would you suggest holding the cellulose in? And actually, another thing is I've got a bathroom that backs up to that, which is going to have a shower. I don't know if you can help me out at all with that. Like, which side does it dry to? Where, I can't really dry it to the bathroom. I don't think.
For ebooks will be precedent, and happy to discuss your specific project at a later time. When we're framing in those new walls, they are non-structural. So whatever shear strength is needed is really just for workability. It's not actually having the same shear loads that a structural wall would have. Historic masonry assemblies are great. We have a lot of old brick buildings that need to be rehabbed, but inherently they are pretty high risk. That masonry is our structure, and it's all outboard of our vapor control of our insulation, and it's getting the bulk water and rain. Typically, we want to keep our structure within our conditioned space to protect it and keep it warm and keep it dry. So we're doing all this work from the interior to help address the moisture movement and energy movement through that brick. For restrooms, we're treating them just like other walls. We are having our standard shower pans or whatever it might be to handle the bulk water from your shower and tub. But that's such a small amount of the day that we don't change the assembly greatly behind that pan. It will dry through diffusion around your vapor closed pan and work through the assembly just like the rest of your walls. So it is helpful to have some point source exhaust system for when you're taking that hot shower, but I'm not changing my vapor permeability for the restrooms. It's for maybe an hour or so out of the day, and that's a small amount of time in the grand scheme of things.
So what is it that holds the cellulose in then?
Oh, yeah, sorry. The Intello has netting built within the membrane to support the dense packed cellulose.
On the brick side?
It's installed on the interior side of the installation. That is not, that gap that you're seeing gets filled with insulation. So we are not creating an air gap. We're holding our framing off of the masonry to then insulate between the framing and masonry. So we are not creating a drainage plane on the interior side of the masonry. I've heard of folks doing that overseas. I don't know of many projects doing that in the States. And I think the detailing would be incredibly difficult because you have floor systems interrupting that. And how would you vent that cavity? And you'd probably put a perforated pipe at the base, but you'd have to like shed it around your windows and doors that would interrupt that air gap. So theoretically possible, but I've not seen folks do that in the States.
So you're saying the cellulose is right up against the brick then?
Correct. Yeah.
Okay, thank you very much.
Yeah.
Great question. Lots of detail there. Now we're over to John.
I've heard with the double stud wall in the Marine 4 atmosphere that you're likely to get condensation on the interior face of an exterior plywood sheathing. And I had heard that the dense packed cellulose helps buffer the humidity within the cavity that should get there and then allow it to slowly drain out or bleed back out into the interior. So Zach, since you're up there in Seattle, what have you heard about the condensation on the interior face of a double stud, like a 10-inch wall?
Zach just stepped away, but I can answer that because
what about Sean?
I'm in Vancouver, and so
that's
again,
close. I'm down in Corvallis, Oregon.
Yeah. Again, on these walls, I mean, mainly because the Intello allows for the drawing to the inside that gets eliminated. But you could see it on, on poly. We've definitely seen it on poly where you get condensation in the summer months on the inside of the poly. That's why the Intello is nice, because any of that moisture that would typically would condensate on the inside of the poly with the Intello.
Is the poly on just behind the drywall?
Yeah. Yeah, so I mean, you're looking at your standard construction of a built wall where you got your cladding, Tyvek 2x6 poly, and then your drywall. On your summer months, you could get condensation happening on the inside of the poly.
On the inside of the poly, just behind the drywall.
Yeah, because you've got inward drying, and so you've got the moist air that's now drying to the inside, and so it gets there. And then because again, there's no way of it getting out, it sits there, and if the wall doesn't dry out because it's got lots of insulation, especially on the north side of the walls, where again you don't get a lot of sun, and that happens repeatedly over season, it's a hard time to dry it out.
What about membrane versus your Tylo or your
the Mento?
The Mento.
Yeah. So again, the Mento again is airtight, and it's also really very vapor open, so really it allows for drying to the outside, which is occurring for most of the year in our climate zones.
John might be
No, I
referring
meant as an interior vapor barrier.
the Certainty membrane product, different vapor variable membrane, but it opens up too soon. So that's where look at that vapor curve, and when it becomes more vapor permeable, is at too low of a relative humidity. It's not quite getting at that throttle point of about 65–70% relative humidity.
And what's the name of your vapor barrier that the 475?
Intello Plus. You see it behind on there. That's the kind of clearer membrane with the green printing, but Intello Plus is the interior membrane for wood framed. In general, I'm a huge fan of double stud, but I would only do it with an interior air barrier. The more we insulate, we're pushing our sheathing layer to further away from our conditioned space. As Sean is highlighting, your high risk point is the backside of that sheathing or the exterior side of the interior air barrier, depending on which season we're on.
Do you use 20% as your sort of guidance point for your dew point inside the wall between interior insulation and exterior insulation?
We like to have the Intello as furthest on the interior as possible, but there are folks studying to show you can have about 60% of your R value outboard of it and still be getting the proper vapor variability function out of the membrane. I am assuming it's all vapor permeable insulation when I'm saying this. And I am a fan of cellulose because of that hygroscopic qualities that you're highlighting, where it's distributing the moisture, acting like a sponge and creating a drying reserve.
No, I was actually referring to a split. I jumped over to a split system with rigid on the exterior of the sheathing and WRB, and then a bib or a bat on the interior surface. So 20% would be outside of that plywood WRB moisture barrier, and 80% would be inboard. And in that case, would you use a vapor retarder on the inside face? So there are two questions: 20% and vapor retarder on the interior.
Yeah. So that dew point analysis that you're getting at will change depending on which site location you're looking at and climate zone.
Right.
So I'm uncertain what it's for.
Well, we're about a 5,000 degree heating area, which is the bottom of the line. Yeah.
But in general, we prioritize that interior air barrier so we don't need to prioritize that dew point analysis. If we're holding our warm conditioned air off of the cold sheathing, now we're less worried about that dew point analysis, which is rooted in trying to warm that sheathing layer. So what you're describing, I would say, sounds low risk than standard construction to me, as long as that exterior rigid insulation is vapor permeable.
Yeah, I was hoping for a rock wool, but you know.
Rock wool is vapor permeable, and I think a good solution that a lot of contractors are familiar with.
Now the owner wants to use an aero seal spray, atomized sealant, air seal.
Yeah, that's kind of, sorry, I'm familiar. That's kind of like a Hail Mary throw for the contractor to try and make the building airtight at the last minute. It's typically done after the drywall is installed, and that's not where we want our air sealing. It has a lot of durability concerns. If it was installed before the drywall was installed and before any bat insulation was installed, then that sounds like you're trying to air seal all the nooks and crannies where the sheathing meets the framing. Theoretically, that's possible. Again, your air barrier is on the wrong side of the insulation. And wood expands and contracts based on our moisture content. So we like our air seals to be able to flex and move as the building settles. So we're tending to use more like acrylic-based adhesives or tapes and membranes I'm not quite sure of the chemical composition of those little pellets. I know they're a little bit elastic, but I don't know how elastic or adhesive they'll be 50 years from now. And we're building buildings for 100+ years. So to me, that approach sounds like you're making up the difference for not trusting your contractor to do it right.
Well, the owner's just all jazzed about it. I don't know. I like to tape my WRB or liquid applied on the exterior and then do a membrane or Intello Plus on the interior tape. So I've got a double air barrier et cetera, et cetera. So
that sounds like a much higher performing solution.
Yeah.
I think a lot of people are trying to find the one-stop shop, the technology will save us approach. And it's not going to save us. Like I think there's a reason why this is a craft and not grab a single product that will solve all of your problems. So to be putting our time and finances into supporting the industry and that craftsmanship instead of trying to develop a technology that will quote unquote save us. It's not.
Any concerns or problems with an R60 or an R80 blow-in a 2x4, a truss, standard truss system at 24 inches on center, sagging or vapor?
There is a point of diminishing returns. R80 sounds really high to me.
Yeah.
That's where an energy model would be able to tell you like, oh, actually stop at R50 because going to R70 isn't worth the finance. So I think, you can over insulate your walls and roofs. What type of insulation you use, the vapor permeability of that material and where you locate it does matter.
Yeah.
A lot of homes that are wrapping their buildings in XPS or EPS are rotting out the sheathing layers. They're trying to address operational carbon use by running exterior rigid foam, but they can be doing more harm than good. So yeah, I would say that's where an energy model or a WUFI or therm model will highlight the point of diminishing returns or the value of doing that type of assembly.
I was looking at the Passive House prescriptive, the new prescriptive, which has a 60 on the lid and a 30 or 33 on the wall. Okay. Anyway, yeah. I've consumed too much of your time. So.
No worries. Thank you for joining.
Yeah.
Good questions, John. And again, Nick, I always appreciate when you always talk about the craft. Sometimes we forget that building is still a craft. It's not just a process. So I'm going to just skip over Megan and Jason for a second and just check on Jane Sanders because she hasn't had a chance to ask any questions yet. So Jane, are you still with us?
I am still here. Sorry, I
Perfect.
joined a little late today, so I missed some of the presentation, but I wanted to join in for the questions. Hi, Nick.
Oh, good.
How are you doing?
Hi, Jane.
I just had I liked your description of how the Intello works, and I know that the Viscon also says it's vapor variable. So I'm curious if there's a way to explain that one, and also what would be a example of a place where you would need that vapor variability in the Viscon? So I would typically use that product on like party walls in a brownstone where your neighbors are there, so you're not exposed to the exterior. Or I also use liquid applied as a secondary air barrier on the inside of the brick, but I still have my Intello. So if I have my Intello for the vapor variability, is there any reason for the Viscon to also be vapor variable? Or would you want it to be as vapor open as possible so that that wall can always dry?
Yeah. So why we're showing that material is vapor variable is because when they do the vapor permeability tests, they do it with a wet cup and a dry cup. So the wet cup is they're saturating the material and then seeing what the vapor permeability of it is. For the Viscon, that came in at a very high number. And then at the dry cup, when the material is truly dry, they do that vapor permeability test again. And that's where the Viscon had a very low perm rating. So that's why we're showing the vapor variability, is because we got very different numbers of the wet cup versus the dry cup. I do not have a vapor curve like I have for Intello for the Viscon, and I don't believe for Klima, the manufacturer, has done that testing quite yet. What's key is it just being airtight in general is what's serving most of the function, the benefits of the material. And then because it will become vapor open when saturated, that means we will never vapor dam with that material. It will allow the assembly to dry through diffusion when there's moisture buildup. So what's it like at 60% relative humidity? I'm uncertain, but I know that it will become more vapor permeable when it becomes saturated or higher water content or moisture content. For treating the interior side of those masonry assemblies, you want something that's at least wind tight, that will prevent the air transported wetting, that will prevent the thermal bypass or wind washing effects. And then the Viscon gives you more tolerance because it's truly airtight. So now if the contractor didn't quite get 100% good Intello install, you have another air barrier to help make up the difference. And it's an air barrier that won't vapor dam and cause harm down the line. So that's why we're very comfortable using it for treating this masonry. I'm a big fan of lime plaster as well. And that material is also vapor variable and does stay a vapor retarder for most of the time. So there's a variety of approaches, but I'd say if it's going for true passive house certification, it's only helpful to have redundancy with your air sealing materials, as long as we're not vapor damming and causing any harm from that vapor damming. So in general, fine to have as many air barriers as you'd like. Just be aware of the vapor permeability. But I don't have a vapor curve for the Viscon. It's just rooted in a wet cup or dry cup vapor permeability test.
Excellent answer, Nick.
Thank you.
Thank you, Jay.
Okay, so we got about 6 minutes until the top of the hour, so we'll see where we get with Megan and Jason, and hopefully we've got all the questions. Thanks, Nick, for sticking around so long. Megan, are you still with us?
Yes, I am.
Okay, fire away.
So my question's really quick. Obviously, it might be ideal to use Intello or 475 products. Sorry about the puppies. 475 products for the home building. But if there's other considerations like contractor familiarity and stuff like that, are there any compatibility things we need to watch out for if we're using, Prosoco or Siga products or anything in combination with 475 products?
I would say there are like warranty issues and concerns. If something does fail down the line, it does get a little confusing for like trying to place blame of like, oh, was it, oh, sorry, that's some loud thunder. Of like, oh, was it the substrate or the adhesive, the material that failed? And that can get confusing when you're mixing and matching from manufacturers. In general, 475 and Proclima materials do not adhere well to silicon. That's really the main material that I know 475 thinks will not adhere well to. The sample backings for like the Viscon and such is just a sheet of silicon or a piece of paper with silicon applied to it. So that way you can uplift it and check out that material. I have primers or special tapes that can adhere well to masonry or other kind of porous materials. But in general, it's best to stick with one system. It's easier to play quality control. Whatever supplier will be more eager to talk to you. It does get a little confusing when I'm talking about a window install and they're using 475 materials in one area but not the other. This is a holistic approach. So there's a lot of variables to be accounting for, and the more we can control those variables, the better. But I know a lot of projects that use Intello air sealing materials for the interior connections of the windows and doors, but then do whatever is covered by the Windows manufactured warranty for the exterior, which oftentimes tends to be backer rod and caulks, which can fail over time and have durability concerns. So I would say just prioritize having a good interior air seal with Proclimo materials.
Perfect. Thank you very much.
Yeah.
Thanks, Megan. And we started with Jason, and I guess we might end with Jason. Jason?
That is the best way to take everybody out. Quick question. I think mine were all answered. I think one of the things was the wildfires I had on there because I'm in California. And I think we're going to create all of California as a wildfire urban. Don't know what the I stands for. Forget. However, I think it was a great presentation. I won't take up anybody else's time. My questions were answered from other people or from the mediators in there. Thank you very much. Nick, you're doing an awesome job.
And Jason, I think it's going to go from California, Oregon, Washington, and BC with that type of code. So,
yeah.
So I guess my question would be for Nick, and any project in California would qualify for maybe doing some case studies or something. I've got some, might be doing a village of tiny homes in the Palm Springs area for a hot springs resort. And that might be a good place to maybe get some modern terrain on there.
Awesome. We're always looking for, especially in process photos or documentation. There's plenty of other resources for like architecture porn type of things. So we're really trying to focus on getting resources for contractors or people working in the field. And Johnny is our marketing director, and he's on the call or Zoom now. And we're always looking for good staging of photos and showing the install in different ways. Nice close-ups of window taping, things like that. So yes, please keep in touch and send us photos or videos, and we'll use our megaphone to share your great work and so others can learn from it.
And on that note, shout out to fellow Passive House California member Mike Horgan and Karen Collective. They are doing a job site walkthrough virtually next week that we're sponsoring, that you can sign up with AIA. Which one is it? AIA, not San Luis Obispo. That's where the project is. Santa Barbara is sponsoring it. So check that out.
Is there any way you could send a link out to that?
Yeah, sure.
And just got to check with Zach if he wants to say any parting words. Nick, great job.
Thanks everyone for joining and taking the time. And I believe the recording of this will be available afterwards. Thank you to Passive House Accelerator for hosting this, and check out the 475 website, but the Passive House Accelerator website, and join all of their great webinars and evening sessions and things. And thank you everyone.
Thank you, Nick. That was really fantastic presentation, and thanks so much for staying for the full 2 hours here. What a great question and answer session. Thank you, Sean, for doing the wonderful job you always do on Q&A Concierge. It was great to have you as a surprise on an entry. Thank you to 475 High Performance Building Supply, and thanks everyone for joining us. Have a great day.